You're listening to Climate Champions, a podcast from the Architects Journal. I'm Hattie Hartman, Sustainability Editor at the Architects Journal. Welcome to Climate Champions, where we offer inspiration and share essential knowledge about design in an era of climate emergency. In this series, we are speaking to innovators and changemakers who are prioritizing retrofit and reuse over demolition and new build.
And I'm George Morgan, Director of 1.5 Architecture.
Stone, you can remove a lump of stone from the quarry, you can cut it on the quarry side, you can drill a hole in it, you can put a rebar through it, and you can post-tension it, and you can have a beam on a truck delivered to a building site with minimal plant. I mean, even I would be capable of doing this, you know? If aliens came to Earth and they saw that underneath the surface was all of this perfect building material and we were going around making concrete and steel, they would think it was a bit dumb. And, you know, people say, oh yeah, you want to build in stone, huh? What are the logistics? What are the logistics of building in a liquid material that has to be delivered on a truck with a revolving tank within 1.5 hours?
Our guest today is Steve Webb of Webb Yates Engineers on why stone and timber, rather than steel and concrete, are the way forward for regenerative building, and how to reduce the carbon footprint of residential extensions by radically reducing the use of steel and concrete. We also talked to Wilf Meynell of Studio Bark about how his practice approaches residential retrofit. Before we talk to our guests, I'd like to direct listeners to the wealth of good content from the AJ Summit held in March. Over 20 sessions, including my keynote interview with this year's American Institute of Architects Gold Medal winner Ed Masria of Architecture 2030, are free to watch until June. You have to register on the AJ Summit website to access the YouTube channel where you'll find all the sessions. Steve, welcome to Climate Champions. We're delighted to have you on the podcast. You're actually the second structural engineer we've had on since our first guest was your former colleague, Maria Smith, now at Bureau Happold. I've spent much of the last decade talking to services engineers about operational carbon, and now, with embodied carbon coming to the fore, structural engineers are increasingly on the front line of sustainable design. Structure and substructure is often where significant savings can be made if considered early on at concept stage. How would you characterize where structural engineering as a discipline is now in terms of sustainability?
That's an interesting question. As you point out, there's been a huge emphasis on carbon in use and reducing the carbon associated with building systems. And actually, I think structural engineers as a profession have felt rather left out of that. Energy in use is an easier thing to measure because you get an electricity bill, you get a gas bill, you can see how much energy is coming into the building because you're paying for it. But actually the structure is very hard to benchmark. So there's no database that says your company does buildings at 300 kilograms per square meter while that really bad company over there at 800. There's no league of embodied carbon designers. So it's quite a hard thing to measure. But we've been exploring stone, and I've been thinking about, we have R&D projects in stone. It's very expensive. We have a R&D budget 50p, and you realize how much testing and research is done into other materials. And then suddenly it occurred to me, yeah, of course, the concrete steel industry pays academics to research concrete and steel. So universities, civil engineering, structural engineering courses are stacked up with academics studying steel and concrete. And therefore, what do they teach? Steel and concrete. When I went to university, 1% of the course was timber design, 0% was stone design, everything else was steel and concrete. We're brainwashed in steel and concrete mode.
So how are we going to change that? I mean, there's so much talk now about curriculum reform for architects. I imagine in engineering there must be similar discussion going on about how do you skill up the next generation for all this.
Yeah, I teach quite a lot, and people seem to be, when they're putting their projects together, their projects tend to be timber by default. But I think also engineers are really trained for safety. So you speak to young engineers that are studying and they say, oh, what's the factor of safety on that? What's the codification? Is the building going to fall down? Your building's not falling down. It's a kind of minimal requirement. It's like Maslow's pyramid of needs. That's quite low down the pyramid. Actually, you have agency to affect other things, environmental, social, aesthetic, and you need to be educated to think about those things as well. So in our office, they had the climate change protests, and people in my office were saying, oh, can we have the afternoon off and join the climate change protests? And I was thinking, well, who are they protesting against? Oh, it's the industry, industry making CO2. Who's that? Oh, shit, that's us. Maybe you better stay in the office and make that office building you're doing out of wood rather than steel, rather than going along and joining the protests. And I think the recognition that we have not only responsibility but agency in that area. I don't think engineers, there's no ethics. People are not teaching timber, they're not teaching ethics. Engineers are possibly slightly self-selecting, static, force flow accountants. And really, they have to be taught broader terms of reference.
You wrote a while back in the Reba Journal about a lack of climate literacy and numerical thinking when it comes to sustainability, and suggested the Range Rover shopping trip as a unit of carbon emissions equaling 400 grams. We can generally understand numbers quite well when it comes to cost, but do we need to get to the point where we're just as fluent in terms of carbon?
Well, I kind of feel two ways about this. I mean, yeah, there's a need to be numerical and to understand these things, but actually I was talking at the one of the Institute of Structural Engineers conferences where people are really calling for greater analysis, more databases, more data, more analytical stuff. And, the other half of me thinks, what the hell do you need all that for? You can see that a forest is better than a steel blast furnace. I don't need a database to tell me that making things out of wood and stone is better than making out of steel and aluminium. If your building's full of steel and aluminium, what the hell do you need a spreadsheet to tell you that for? Ridiculous. Just recognize, use your brain, engage your brain and think about what you're doing at your desk with your pencil, and like, oh, steel bookcase, that's rather nice. Got any locally grown tomatoes, and let's cycle home because it's good for the environment.
Steve, let's talk about some of your projects. Could you describe a project where your early involvement has dramatically changed the embodied carbon and presumably also the look and feel of the project?
Well, I'm a little outspoken, so I'm quite happy to say to a relatively conservative client, have you thought about making your building out of wood? Or have you thought about making it out of stone? I think a lot of engineers and architects are afraid to ask. So York House was our project with DMFK in Pentonville Road, which the contractor really wanted to make a steel and concrete frame.
To the extension of the new part.
So so it's the existing building is a big existing concrete building, and it has a roof extension and a front extension. And the contractor's saying to the client, you want this quick, you want this at a reasonable price, then this is what you've got to do, and I really, was digging in to the point of, not doing ourselves much good in terms of standing on the design team, banging on about timber all the time. But we stuck to that, and we argued the point, and we examined it in different ways, and eventually they came around and they built it with timber, and the contractor did a great job. And I hope that next time that contractor will be less resistant. But people are prone to build what they like to build with the people they know in ways that they understand. Construction is so full of risks and cock-ups that who wants to introduce a new material and just add another 50 problems? When we're designing in timber to a certain degree, and especially when we're designing in stone, if somebody asks me a question about concrete and steel, I know the answer immediately because I've designed so many concrete and steel buildings. Nothing requires a lot of pondering. Oh, how's the contractor going to build this? Well, he's going to build it like he always builds concrete. He's going to build it like he always builds steel. Everything is established and understood. the etiquette of how you commission the contractor and what the detailing needs to be and how he likes to do the connections and all that kind of stuff. Whereas using different materials needs to be thought out from scratch every time, and everybody has an opinion. The builder has to build it in a different way to the way he normally builds it, and you need to think about where he's going to put the crane, how he's going to crane it in, how he's going to screw it together, where's the scaffolding going to go, where's it going to be ordered in from. In stone especially, there's no clear answer to all of those questions. Take ages to answer, and there's a lot of argument. So it's a real impediment that there's no standard. So it's like, you've been used to eating beans on toast at your house in England, and suddenly you've ended up at a Japanese tea ceremony and you don't know what to do. So this really slows us and requires a lot of extra effort, which is why I think in many cases people don't want to promote that, and they don't want to, because building is difficult and nobody's making so much money that they can spend 50% of their time dreaming about new kinds of details.
Because you've done quite a bit of research about how timber can be substituted for many of the typical steels that get used in the kind of domestic refurb project that will be the bread and butter for a lot of our listeners, an extension to a Victorian terraced house. Myself, I'm working on a project with Simple Works as engineers where we're doing this, trying to use timber instead of steels. In this example, you've outlined a dormer, closet rig extension, through lounge, and removing a chimney breast as the typical elements. Could you talk us through how this could be done with timber?
Yeah, we started our practice doing domestic refurbishment because we were quite young and we didn't have a massive Rolodex of amazing contacts. So we were just kind of back extension, loft conversion people in the beginning. And, you would see people would deliver steels. They would be kind of 1.5 ton steels dumped on the pavement. And these guys would pull these steels up into the loft. It just seemed ridiculous. Victorian houses, even big ones, big Victorian buildings of Belgravia and stuff like that, they're all built with timber. So we started designing, so this would be like maybe 12 years ago or something, we switched out a steel portal frame in a building in Richmond with Architecture WK and transposed it for an LVL beam, Curto, and just switched out the steel. And I was thinking, that's like 1.5 tons of steel, which is 4.5 tons of carbon dioxide, and the timber is negative. So maybe the difference is 6 or 7 tons of carbon dioxide in that one tiny back extension, which is like, for us, 3 days work or something.
So that's the same as the carbon in like making a Citroen C1 or something, isn't it?
Yeah. It's like your annual allowance. If you're a prudent person, maybe you're on 9 tons a year or something, going on holiday and flying around and driving your car and whatnot. So a 6-ton decision on for a house build, it's quite a lot. It's quite powerful. But the timber beams are a bit bigger and everyone's worried about timber rotting, and people find it very strange that timber supports masonry. And how long is it going to last, And so we always have these debates. Oh, I want something durable and that's going to last a long time, Okay, so timber rots, but steel rusts. I think there's an 800-year-old timber chapel in Thaden Boys in East London, and there's a viaduct in Hammersmith that's only 50-year-old that's falling to pieces. Everyone says concrete's more durable than timber, especially in domestic. So we would reinforce the existing timber in the loft with stress skin. So basically just glue ply to the existing timbers and make them stronger. Use the spine wall to take the load, which is how the houses were originally designed. There's a limit to what you can do with timber for supporting masonry, but we try and get rid of the steel portal frames. The biggest travesty, I think, in domestic construction is, when you see these sites that people dig 600 millimetre wide in clay soil, maybe 2 metre deep foundations all the way around the perimeter of the building and stick a brick facade on top of it. The volume of concrete, the amount of digging, bricks are terrible for the environment. They are made with lignite or other kinds of coal, maybe modern. So I'm maybe doing a disservice to the brick industry, that there are more modern, probably gas-powered kilns that are more efficient. But bricks are very heavy, not particularly strong, and kind of crazy as they're only an aesthetic choice.
You talked about using oak mini piles as foundations if it's on a lighter building. So it seems a bit surprising to hear of timber foundations.
Well, so we would build domestic extensions with suspended timber floors. We'd have isolated concrete footings rather than full full perimeter strip footings. We'd take all the other steel out. We'd have a timber roof. We'd probably, advocate brick slips rather than real bricks, to bring it, or recycle quarry tiles in one go to bring it down to kind of lighter. But how do you get rid of the concrete footings? So I spoke to A Squared, who are a geotechnical company that we work with a lot, and they were saying that, oh yeah, you can do a timber pile. You just stick a shear vane into the top of the clay and you get the strength of the clay, do a very quick calculation, and then you know how much load the timber pile will take. And you can buy this 300 quid fence post whacker. So I said to this builder, so if you had to dig, and this manual excavation in people's back gardens, if you had to dig that size of footing, or you had to whack in this fence post, which is 2 weeks work versus 20 minutes work, which would you prefer to do? And unsurprisingly, they're like, oh yeah, could that work? And then there's the durability question. I think oak piles are being dug out of the Thames periodically from the Roman days, so I presume an oak pile is going to last quite a long time.
Let's talk for a minute about the use of timber in large retrofit projects. You've recently worked on the retrofit of the Grade 2 listed Art Deco Hoover building on the A40 Westway into 66 flats. There you substituted timber for steel in a number of places. Can you describe a bit about that project for our listeners?
Yeah, so the Hoover building was obviously the Hoover factory at one point. There's a Tesco's behind it and slightly underneath it. So our client bought a lease on it and wanted to turn it into flats. We were the second engineer, and the previous engineer, who'd done a reasonable job, had a steel frame structure to support the building and to support intermediate floors. And we floated the idea of removing all of the steel work and using the partitions and gang nail trusses within the partitions to do the job of the steel. So between all of the apartments, there are walls. Gang nail trusses are the kind of Barratt home roof stuff. Very, very low cost, effective. They make big timber trusses and they press nail plates into them. So we used 2 or 3 of those bunched together to make big roof trusses that supported these flats across the width of the Hoover building, and they formed the partitions at the same time. So the client on that project had no particular sustainability aspirations at that point, but really saved quite a lot of money by taking the steel out. So that lightweight timber was cost effective for our developer, and I think removed about 30 tons of steel. So improved our carbon karma by about 90 tons.
I also wanted to talk to you about brick, because you mentioned brick, and brick architecture is proliferating across London at the moment. Sometimes it can be very difficult to avoid using brick, and sometimes clients absolutely insist on it. But brick with cement mortar can be really hard to reuse at the end of a building's life. Are there good structural reasons why we can't go back to using lime mortar so that bricks can be more easily reused?
Brick is a kind of crazy material. I think there were reasons why people developed bricks in the first place. 7,000 years ago, they were mud bricks, and 4,000 years ago, they started to fire them in the post-pottery period, or whatever it's called. And London is, in inverted commas, a brick city, but it wasn't always a brick city. And before the Great Fire of London, it was a wood and wattle and daub and stone city. And only after Charles II decreed that everything had to be made out of brick or stone were people really using bricks. Bricks are a relic of the coal era. When they were building bricks for Victorian houses, they were building 8-inch walls. And you need bricks to be 8 inches thick so that they can resist wind load and carry vertical load, because brickwork is so weak. If you have a 4-inch thick brick wall, most people could karate kick their way through it. It's not very strong. As a consequence of, therefore, of building cavity, because I suppose Victorians were living in colder circumstances with 8-inch brick walls, insulation wasn't high on their priority list. But when you make a wall into a cavity wall, you weaken it tremendously. So something which is twice as thick is 4 times as strong. So it's a kind of rule of squares. So something which is half as thick is a quarter of the strength. So a cavity wall is a quarter of the strength of an 8-inch wall. that necessitates making everything out of cement mortar. Cement mortar is really strong and brittle and inflexible, which means every house built with a cavity wall with cement mortar has to sit on huge foundations very, very deep, because the building's not as flexible as a Victorian building was going to be. Also means when the brickwork expands with moisture, it's very sensitive to cracking and movement, so you need mastic movement joints everywhere. You need horizontal mastic movement joints, cavity trays, shelf angles, wind posts, and you can't make a cavity wall span from floor to floor for wind load without having some alternative support. So it's just a really weak material. I mean, I really don't like brickwork. I mean, I like brickwork aesthetically. I have nothing against it, but in a modern building, it's only a decoration. It's 100 millimeters of solid ceramic decoration, where maybe a brick veneer of some kind would be more efficient. And we were doing a big project with a house builder, 16 story tower, and I was saying, look, at 16 stories, why don't you just do clip-on tiles? Oh no, we want proper brickwork. There's nothing proper about 100 millimeters of decoration over 30 millimeters of decoration. It's all fake. It's just 900 tons versus 200 tons. All of the frames that support the brickwork need to be over-designed so they don't move and crack the brickwork because it's so delicate. All the foundations to carry them, it's just, what is it? I really don't understand. I think it's crazy. It's a self-perpetuating aberration against logic. I specify brick because there are bricklayers and because planners like it. Builders like bricks because there are bricklayers, and architects choose it all the time, so they make more bricklayers and they make more bricks and they invest in more kilns, and it's all, and at some point somebody has to say, this is bloody stupid. This is a, medieval material. We not time we do something different.
But you try and do something different, and then there's a lot of concerns raised about maintenance or fire. It can be like a lot of time spent demonstrating that no, it's actually fine.
Yeah, that's the thing, is that you need to think more about something you don't do every day.
Well, that's a perfect segue into talking about stone. And Webb Yates, with group work and the Stone Masonry Company, put on an amazing new Stone Age exhibition at the Building Centre in London last year. Stone projects can range from dramatic staircases in private homes, which are expensive, to group works, Clerkenwell Close project, where the argument was that it was cheaper to use natural stone as the structure than steel or concrete. We've not been using stone much as a structural material in this country for the last few hundred years. How can we get it back?
Well, people do use stone in this country, and they continue to do so, but not in a very sophisticated way. And I think stone has lots of advantages. A, it's massively abundant. There's an inexhaustible supply of stone compared to edification volumes. Stone is much stronger than timber, evidently. If you grow a tree in a 5 by 5 meter plot, for example, after 25 years, you get about 1.5 cubic meters of material with a strength of 7 newtons. If you dig up the 5 by 5 meter plot to a depth of 20 meters underneath the tree, you get 500 cubic meters of stone with a strength of 150 newtons. So it's infinitely more powerful to quarry for stone than it is to grow trees. And actually, small numbers of very compact quarries are probably less damaging for the environment than widespread monocultural forestry. Concrete is cement production. So we would get a stone, limestone, crush it, burn it, turn it into cement with huge amounts of energy, batch it. When the stone in the ground in the first place was perfectly usable. But stone was dropped at a point in history when I suppose people imagined growing inexhaustible energy supplies with no environmental consequences. So why would I use stone when I can homogenize it with coal and have a totally reliable product that I can pour into any shape I want to? Yeah, that makes sense. If you reintroduce the environmental consequences of that, maybe those people would have carried on building in stone. I was joking. If aliens came to Earth and they saw that underneath the surface was all of this perfect building material and we were going around making concrete and steel, they would think it was a bit dumb. And, people say, oh yeah, you want to build in stone, huh? What are the logistics? What are the logistics of building in a liquid material that has to be delivered on a truck with a revolving tank within 1.5 hours? Oh, that's great. You can remove a lump of stone from the quarry. You can cut it on the quarry side. You can drill a hole in it. You can put a rebar through it, and you can post-tension it. And you can have a beam on a truck delivered to a building site. with minimal plant. Even I would be capable of doing this, Even an email warrior like me could do something like that, It requires no infrastructure, no industry, no processing, it's right there. So if the government, if you wanted a really good green building material, it would require, on a national level, little investment in R&D, codify it, write some codes, work out a grading system, open some quarries. But I don't think our industrial policy is ever that active. And the stone industry is geared towards decorative products. Stone is expensive because 50 or 60% of everything that's quarried is thrown away because it's the wrong color. All we can do is demonstrate the feasibility and indicate that strategically this might be an interesting thing for cleverer people than me to figure out.
One thing that might be an opportunity is the government's ban on including combustible materials in external walls over 18 metres. In the Stone Age exhibition, there's an idea for a stone tower. Could you tell us about that? And have you had any nibbles of interest?
Well, the stone facade is like Ameen's building in Clerkenwell, extrapolated upwards. We looked at stone floor plates. So we had the stone floor plate in the exhibition outside as a post-tensioned beams and floors that could span 12 metres to create a column-free office space. I think every new material emulates the previous material. So when they built Iron Bridge, they built it from cast iron, but they connected it together as if it was carpentry. So they have mortise and tenon joints and wedges because they only understood carpentry. So when they made cast iron, they're like, oh yeah, we'll just use mortise and tenon joints because that's all they know. When they were building with concrete, when Maxwell Ayrton and Owen Williams were building the Empire exhibition at Wembley, Owen Williams getting totally frustrated with Maxwell Ayrton because he wants to make everything neoclassical. So he's making concrete look like stone all the time. And I think Owen Williams wanted to build boots, wets and other things in more of a concretey style. And I think CLT is a copy of concrete flat slabs. People are comfortable with it because it's fat like concrete, rather than it being a lighter structure. And I think the stone thing, with the thing that we did in the building centre, we're emulating concrete with stone. So we're making our stone look like post-tensioned precast concrete planks, which are not intentionally, but that's all we know, and then we're just too dumb to figure it out. And also people are like, oh, that's quite good. That looks like a post-tensioned concrete plank. But really, stone reinvented with modern analysis and manufacturing techniques will have a different pragmatic ecosystem to what it had 150 years ago. And when it's adopted, or if it's adopted widely by a Darwinian process of discovering what's expensive and what's not expensive and what's easy to do and what's not easy to do, it will gradually adopt its own language from a kind of technical and practical point of view, which then will translate into some kind of architecture, I suppose. A bit like steel and high tech.
Because one of the contemporary technical requirements would be about, as well as the embodied carbon being low, about the operational emissions of the building being low. So when using stone on external walls, there's, I guess, a question of where the insulation goes. So you can either display the stone on the outside, but then that means connections through to the floor slab would go through the insulation zone and be a cold bridge, or you could insulate on the outside, but then that would hide the stone. I guess a stone cavity wall would end up being too thick.
Yeah, what we need is brick-shaped red stones and block-shaped grey stones. There's every way of building with stone that isn't... all of those problems, cold bridging and everything else, are problems that exist in masonry and other materials, and they're all solvable. We came to so I was looking at, because of the fire regulations, panelized precast concrete systems and panelized timber systems are very similar. So you could build towers with precast concrete walls and timber floors, and actually the volume of the floor is much higher than the volume of the wall, so on balance they're carbon negative. But when we were extrapolating that to say, a hybrid construction, here's a new idea, hybrid construction, stone walls, timber floors. Wow, we really cracked it there. Only been going on for 7,000 years, Totally ridiculous.
Steve, I'd like to step back for a moment. We've been asking our guests to share with us their kind of wake-up moment in terms of climate emergency. When did sustainability become a serious focus for you?
For me, timber gives me a good feeling to use it. And I think people have a good feeling around it. And it just makes me happy to make something out of timber rather than out of steel. Who knows what the consequences of sustainability are going to be. I'm sure our planet will grow back life with or without humans, and inside me, the thing that drives me on is that I just prefer timber to steel. It just makes me feel better, and stone as well. And I just like the idea of using natural materials, and it seems logical to me to use something which is available and provided by nature and not use some industrially manufactured products. But I think it's a visceral thing.
On another note, what are your thoughts about Lacaton and Vassal winning the Pritzker? I heard Anna Lacaton speak in Cairo 3 or 4 years ago, and she takes pride in saying that on one of her Bordeaux projects, she was asked to look at a public square, and she advised the client not to do anything at all. What's your take on that?
I read that. I love that. Absolutely. God, we build so much crap. The museum needs a cafe, it needs a cafe and a small extension because of this, that, and the other, and the house needs an extension, and this needs an extension, and that needs an extension, and everyone's adding bits and pieces, and no architect says, oh no, I don't want a project, because we're all so bloody hungry, or engineer, we're also hungry for work, and winning work is everyone's biggest preoccupation. But God, yeah, you think so many developments, do we need them? I think it's wonderful that she said that, and I totally agree.
I think that's a great place to stop, Steve. Thank you. Thank you very, very much.
Thank you for having me.
Our second guest is Wilf Meynell of Studio Bark, who will talk to us about how his practice approaches residential retrofit. Wilf, it's great to have you on the podcast. We've just been talking to Steve Webb about ways to reduce the whole life carbon footprint on Victorian terraced house retrofits and extensions. This is bread and butter work for many of our listeners and so frequently featured in AJ Small Projects. How does Studio Bark approach this?
Yeah, this is $1 million question, and one that is ostensibly quite complex, but I think we're learning some methods. I think just going back one step, I think it's important to kind of be aware that embodied carbon, which is a big factor, has for a very long time been the construction sector's kind of dirty secret. We've been way too focused on, in a good way, very focused on reducing energy consumption. And as we've improved that, we started to realize that actually the embodied carbon is playing a more and more significant role. And I think one thing that seems to get lost is sometimes the context. And I think that goes for, or sustainable architecture as a whole. But actually the very specific context of, let's say, a Victorian house is completely relevant. And I think that's what was very interesting about Steve Webb's kind of analysis of how to do the engineering potentially of a Victorian retrofit, was that the context is the house, and it's how it's built, and it's the materials that it's built with, and it's simple principles of physics that are kind of why that building is how it is. And sadly, I wish there was a kind of one size fits all solution, but it's just not like that. We've got a very old building stock with lots of nuance. And, if everything was the Victorian terrace as it was built 100 plus years ago, I think it would be easier. But there's been so many micro changes between then and now that we just have to be adaptable. We need a very good balance between science-led measuring methodology and the on-site understanding the physicality of the materials that we're dealing with.
That's really, really interesting. So how do you decide how deep a retrofit is appropriate on any given project?
Yeah, so that's another very difficult question. And I think that, again, is down to maybe finding a nice balance between ambition and realism. And I guess the first big question really on that is money. And I think, again, architects don't find that word very easy to say. We tend to say it a lot, and we try to say it a lot at the beginning. And actually, I think as a result, we probably lose most of our clients, sadly. But we would much rather take on a project where the budget is feasible and we can make an impact. Way too often, there can be great projects with fantastic environmental ambition, but when the budget comes in 50% too much, all of that nice, natural, fluffy insulation gets ripped out. And you can end up with a building which is environmentally quite bad when your ambitions are actually quite high. So I think if we start from the money, and I guess a very relevant factor in money is something that the AJ has been lobbying a lot, which is VAT. We need to change the tax incentive. It's completely the wrong way around and it's mad. But I don't really want to get into that because I'm sure you've covered that a lot. So I think we are up against it. And sadly, if a client is commissioning an architect, they're already in that very top 1 to 10% of people who can afford to do that. So big political change is needed to really address the balance here. And we are in the world of architecture, so we are dealing with this. We need to understand what the budget is and what they're after. So are they after a 40 square metre extension for, I don't know, £100,000, let's say, £2,500 a square metre? Now, is that feasible? Probably yes. But is that feasible if they want to do significant works to the rest of the house? Probably not. So at that point, you need to understand, do they only care about square meterage, or do they have greater ambitions? And often what we find is that we're constantly pushing the scale of our projects down because we're trying to be more feasible with the budget and we're trying to retain the good thermal envelope and the nice natural materials, the good timbers, the good quality of light. So I think that's critical, really, is just to make sure that the expectations are right. And then really we'll go as far as we can go in terms of a deep retrofit. We will start on the scale of quite a light touch retrofit all the way up to a deep retrofit. But we're not going to force that upon a client if it's not suitable.
Yeah, you've mentioned sort of foam-based insulations. What's your take on natural insulation generally?
I often ask a very simple question to architecture professionals. And I don't know the answer to it, and that's partly why I ask it. So what is better, 100 mil of PIR, foam-based insulation, or 100 mil of wood fibre insulation? And I ask that because what you're doing is you're pitching other environmental factors of PIR, petrochemical-based, toxins, high water usage, not a waste stream, various other issues, versus the better U value it theoretically provides. So theoretically, the 100 mil of PIR gives you a twice better U value than the wood fibre. But there's other factors. It's just not that simplistic. And building regulations have been very much focused on U values. Hence, PIR has really won over the market. At the moment, I think in the UK, recent stats suggested it's something like 0.2 to 0.3% of the whole insulation market is natural insulation materials, which to me is mad. That's partly driven by building regs and lobbying and politics, whereas actually the reality of something like a dense wood fibre insulation wrap is that, yes, it has half as good U value, but it also has other benefits. It has high thermal mass, so it's good at kind of limiting radiant overheating, way lower carbon. It also sequesters carbon. Often with natural materials, they're easier to find local sources. Obviously, not always the case. Often these natural materials come from waste streams. So, sheep's wool, which has its problems because it's linked to the meat industry to some extent. But timber fibre, pulp timber fibre is a waste product from other timber industries. And I guess one of the other real critical things around natural fibres is that they're hygroscopic, which means that they're kind of open to moisture and they're very good at regulating that moisture. So when we're talking about retrofit, combining old buildings which might have moisture already inside them or might have small leaks. Having a material which doesn't trap the moisture on, let's say, timber structure, which could lead to rotting and ultimately structural failure, having something which allows that moisture to move through it is just a no-brainer.
So, Wilf, let me ask you one more thing about Steve's approach. I mean, these things like reducing the steel and reducing the concrete, looking at something like oak piles, I mean, are these things that Studio Bark does as a matter of course?
I mean, I'm not going to be as bold as to say we've done everything that Steve Webb is suggesting. And I think what he's suggesting is quite provocative and really positive. And I want to see more of this kind of thing happening. The problem we would often have is actually structural engineers, or historically structural engineers, and then building regulations. I think your local duty building regs officer coming out and seeing an oak pile being driven into an extension project is going to have a bit of a heart attack. But I think no, we've always worked really hard on the structures, because we've always been aware that actually, we can play around with more environmentally friendly cladding, but ultimately, if you're going to be pouring hundreds of tons of concrete into the ground in the first place, it's almost an irrelevance. So we've been looking at other types of foundation systems. We've done quite a lot of work with screw piles, so obviously not oak. I think there's a really interesting question around, and I don't know the answer again, but oak, where does it come from? Is it English oak? Was it cut down specifically to make this oak pile? How long will it last? Is it installed correctly? Versus a steel pile, which ultimately might be easier to unscrew at the end of its life and be reused again. So I think it starts to ask the questions around circular design principles. And the one thing I do know is that cast concrete with reinforcement is not a circular material. Analysing structures and reducing the carbon intensity there as a first port of call is fantastic. And I'm so excited by what's going on in the structural engineering industry around embodied carbon. There's just so much movement.
Very interesting. So before we sign off, I wanted to just ask you what's in your pipeline at Studio Bark that you're particularly excited about at the moment?
Obviously, we do quite a lot of smaller domestic projects. We've got a few interesting projects on cult houses, kind of timber framed houses that came out post-war and were built a lot around the 60s, 70s. Going back to the talk about engineering, they are absolutely the most efficient structures you can build. They're really 70 mil studs sometimes, no insulation because it was before that time, minimalist truss frames with roofing battens and cedar shingles, no membranes, nothing, just everything allowed to breathe. And although obviously that's not fit for purpose, because it's essential that we don't waste energy. If we pump energy into a building, we need to try and retain as much of it as possible. So I'm not saying we shouldn't use insulation at all. But I think, learning from that, thinking more about adaptive reuse. And that's a bit that I think I'm most interested in. It's not just about rebuilding old buildings as they were, but thinking about the future. How might our Victorian terraces look in 50 years, not in 5 years? And what can we do that's maybe careful and considered that improves that, but also allows for Mr. and Mrs. Jones to come in 15 years after our flashy extension to rip it all out and start again? And then I guess one other project that I'm quite excited about is our kind of sister company, UBuild, is working on quite a kind of high profile building in Westminster, but it's very much sustainably focused around adaptive reuse and circular economy. So, how can we actually do temporary adaptations to historic buildings to give them a new lease of life, but without dramatically changing the fabric and historic context of these buildings?
One last question. Your colleague, Nick Newman, has just edited a book with Sophie Pelsmakers that's come out, Everything Needs to Change. And it's about the paradigm shift that Michael Pollan of Architects Declare always talks about. Can you give us the headline messages from the book?
Yeah, headline messages. I think the title says it all, everything needs to change. It's really simple. And I think it does get very political. And I think that's important. I think the construction sector in general is just so polluted with high-level corruption and cronyism that we do need to change everything. We do need activism We need people to shout. We also need people to find solutions. And technology can solve some of the stuff, but it can't solve everything. We know that technology can be both used for positive and negative aspects of environmentalism. We have just so much greenwash out there. What the book's really good at is also highlighting some really positive stories around what people are doing, whether it is protest, whether it is through ACAN and lobbying government. Huge amounts of movements now happening in the ACAN embodied carbon group, which I'm kind of involved with time to time. We're getting lots of letters out to MPs, we're getting responses, we're getting parliamentary questions. Embodied carbon, which didn't ever used to crop up in any sort of government briefings, is now popping up everywhere, which is really positive. The RIBA are changing quickly in terms of in education, which is really positive as well. So I think, and that piece in the book, from the education campaign group is excellent. It's such an exciting time. I think we're all absolutely knackered because it's stealing all of our free time, but it's just amazing to see that movement, and I really hope it can roll on.
Thank you very much, Wilf. That's a great place to stop. I also feel like, there's just a sea change happening, so we just have to keep pushing.
Yeah, absolutely.
If you're enjoying Climate Champions, please rate us and subscribe on your favorite podcast platform. It helps people find us so we can build an audience. You can find the show notes for this and previous episodes at architectsjournal.co.uk/podcasts. Thanks for listening.